Okay, so now we begin Unit 2. The intro to this one's going to be a little bit short, but we're going to power through. Let's do this. So, this should give you an idea of the powers of magnitude and each size scale. The human eye can resolve things to about 0.1 or so millimeters, maybe a little bit less. So you can resolve things that are really super tiny, but yeah, you have to have pretty good eyesight for that. Light microscopes have a good range from 1 millimeter all the way to about 200 or so nanometers. Electron microscopes have a real wide range from 100 micrometers and maybe a little bit up, depending on what kind of electron microscope, all the way to the partial nanometer scale, to the fractions of nanometers. So eukaryotic cells are in the 10 to 100 nanometer range. Organelles of those eukaryotic cells are in the 1 to 10 nanometer range. Bacteria are in the 1 to 5 or 1 to 5 nanometer range. Viruses are smaller than 100 nanometers. Proteins are smaller than 10 nanometers. Lipids are smaller than 5 nanometers, or smaller than 3 to 4 nanometers or so. Molecules are smaller than 1 nanometer, like water, that is less than 1 nanometer in size. And atoms are on the scale of picometers, which are even smaller still. So, an introduction to magnification. Now, magnification is the number of times larger an image is compared to the real size of that object. So, magnification is equal to image size over actual size. M equals I over A. This is your mantra. This is so important. This always shows up on the Cambridge exam. Magnification is equal to image size over actual size. So, if I were to take an image that is a poster board, a picture of something that is 1.5 meters in diameter across, the image itself, the poster, is of something that is only 10 millimeters in size. I need to convert my units to find what my magnification is. I need to do dimensional analysis and unit cancel, which is basically a fancy way of saying unit cancellation, to convert this. I know that there are 1,000 millimeters for every 1 meter. 1,000 millimeters for every 1 meter. So I am going to multiply this 1.5 meters of image size and 10 millimeters of actual size by 1,000 millimeters over 1 meter, because that is my conversion factor that I require in order to cancel out meters and cancel out millimeters to get 1.5 times 1,000, that is 1,500, divided by 10, 150. So this image, this poster, a 1.5 meter poster board of an image of an object that is 10 millimeters in diameter, is 150 times magnification. All right? So, the magnification equation, M equals I over A. The total magnification is the magnification of the first lens multiplied by the magnification of the second lens, multiplied by the magnification of the third lens, by the fourth lens, by the fifth lens, by the sixth lens. However many lenses you have, the magnification of that lens multiplies by the next one. So if I have a lens that magnifies times 10, and another lens, lens 1, lens 2 magnifies by 40. If I look through the first lens, whatever I look at will be 10 times the size it should be. If I look through the second lens, whatever I look through will be 40 times the size that it should be. If I look through both lens 1 and lens 2 at the same time, I am multiplying this by this. That gets me 400 times magnification, because 10 times 40 is 400. So, in a microscope, a light microscope, the eyepiece magnification is our first lens. The objective magnification is our second lens. So that our objective in our low power, our red objective, is 4 times. In our medium power, our yellow objective, is going to be 10 times. Our high power is our blue objective. It's going to be 40 times. Our ocular eyepiece is going to be 10 times every time. So 4 times 10, 40. 10 times 10.